We've come a long way since the Frenchman Girard and his son patented the first wave energy device back in 1799. The world was a different place then, with minimal pollution and no greenhouse effect to worry about. Since then, there have been many differing forms of energy generation with varying degrees of renewability, from windmills to watermills and from horsepower to fossil fuel. But there is an effective source of renewable energy all around us: the oceans of our planet. The burning of fossil fuels over the past 50 years has resulted in increased levels of CO2 in the atmosphere. This is leading to global warming with the resulting consequences for our lifestyles and environment. Scientists and engineers have been working hard in the search for sustainable ways to feed our communities with electricity. The case for ocean power has always been strong. Ocean power technologies are based on well-understood principles derived from physics, marine design and construction, and on sound mechanical and electrical engineering. Principles and practices which have been understood for hundreds of years. The energy in waves comes from the wind as it blows across the surface of the ocean. The energy in waves is tremendous. An average 1 meter, 10-second wave striking a coast can deliver more than 7 megawatts per kilometer of coastline. Tidal energy relies on the movement of the moon around the Earth and the Earth around the Sun. The gravitational pull moves billions of litres of water thousands of miles in relatively short time spans. No man-made device could do this. These vast movements of the sea carry within them non-polluting, reliable and predictable energy. As well as the massive movements of the tide, there is always an unseen underlying flow. This flow moves millions of litres of water per second. By placing turbines in the flow, the energy can be harnessed and converted to electricity. In the Bay of Fundy, the first Canadian deployment of commercial tidal turbines on an unprecedented scale is proposed. It will provide the potential to power over 20,000 homes and will be the largest tidal stream generator in the world. In Strangford Lough, off the Northern Irish coast, a tidal flow generator has been in operation for more than 5 years. It operates in an area designated as a wetland of international importance and is protected by the UK as an area of special scientific interest. The project generates 1.2 megawatts, enough power for around 1,500 homes. The potential energy contained in the difference between the height of water at high and low tides can be harnessed using technologies such as tidal barrages. In northern France, the first large-scale tidal power plant became operational in 1967. The world's largest tidal barrage installation began construction in 2011. Siwa Lake Tidal Barrage near Seoul in South Korea now supplies electricity to 2.7 million people in the nearby city of Incheon. Where freshwater rivers meet salty seawater, the difference in salinity can be used to generate electricity. The principle is simple. Saltwater and freshwater are separated by a semi-permeable membrane. The freshwater migrates to the saltwater, thus increasing the volume and consequent pressure. This can be used to drive turbines and generate electricity. Ocean thermal energy conversion makes use of the vast solar energy stored in the upper layers of the ocean. Heat from the warmer surface water is used to vaporize a liquid such as ammonia. This rotates a turbine which drives a generator to produce electricity. Deep, colder ocean water cools the ammonia, which condenses back to liquid to be heated again in a 24/7, 365 days a year cycle. OTEC energy is best used offshore in very deep water. Ideal locations are found along the equator, where the surface temperature can be as much as 30 degrees centigrade higher than the deep water below. Throughout the world, there is a growing confidence that the technology is maturing. The main challenge is the development of reliable and cost-effective technologies to harness the huge renewable energy potential of the oceans. For this to succeed, clear government commitment and targeted funding is needed to create an environment that encourages investment from large multinationals. The International Energy Agency supports international energy technology research, development, deployment and knowledge transfer through multilateral groups. Ocean Energy Systems is one of the initiatives within the International Energy Agency. It was formed to unite the efforts of every country in bringing ocean energy to market as a practical economic alternative to traditional fuels. Year on year, more and more countries commit to this cause in a spirit of global cooperation and intent. It is the 2050 goal of OES to grow the installed wave and tidal energy capacity to 25% of the world's requirements. This will create an estimated 300,000 direct jobs and save nearly 1 billion tons of CO2 emissions. As the 21st century matures, just two things are certain: the increase in climate change and global warming, and the ability of the oceans to deliver a predictable, renewable, perpetual, carbon-free and sustainable energy supply.